Hello everyone, this is Dr. Esperanza, and for today, we're going to be working on the fourth type of variation, which is combined variation that represents rational expression, and we're going to be answering word problems associated to this type of numerical relationship. And just like how we answered problems from our previous lessons, in working with word problems involving relationship or variation relationship, you need to first establish the type of variation you are working with, converting your verbal statement to algebraic form, and then answering your specific algebraic problem from the given information that you have from your word problem. So let's answer some of the equation that is related to combined variation. And what is combined variation? Just like from the word itself, it's just a combination of two or more relationship that we're going to be working on today. So if y varies directly to some quantities and varies inversely to some other quantities, the formula or equation that we're going to be using associated to this type of variation problem, where k is the constant of variation that we're going to be watching out for, is going to be x, y is equal to kz, or y equal to kz all over x. So this is the specific format of the equation that we're going to be formulating based on the given variables that we're going to be working on in our word problems. So just to have a recap of the type of relationships that we've had from our previous lesson on variation, we had direct variation represented by y is equal to k times x. We also have the inverse variation wherein y is equal to k all over x. And we have joint variation where we are working with two or more variables in order for us to produce our output given by y equal to k times x times z. And for today, we're going to be using combined variation, which is we're going to be working on two or more relationship or combination of any of those three relationships that we've had from our previous lessons. So now let's work on one of the most important part of answering word problem involving variation is translating your verbal statement into its algebraic form. So we have here y varies directly with the square of x. So our clue here is that we're working with direct variation, and we know when we are working with direct variation, we're working with the formula similar to y equal to k all over x. So by translating our statement into its algebraic form, so let's have y varies directly with the square of x. So this is our variable x, and we know that in this particular relationship, we will always use the constant k, or the constant of variation. So if we're going to translate this into its direct variation format, looking like y equal to kx, our equation will be y equal to kx squared. So this is the specific formula that will satisfy this particular relationship that we are working on. So we have y equal to k times x squared, and changing it into its standard form, we can rewrite it as y equal to kx squared. So this is our first translation. So working with the second translation, which is z varies jointly with x, and the square root of y. So we're working with joint variation, which means we are working with two or more variables for our given output. And in this case, the output is the z variable. So we will have z varies jointly with x and with the square root of y, And we know that whenever we're working with variation formula or relationship, we always have the constant k in our equation. So in translating this into its standard form, we'll have z is equal to k x and square root of y, which is the formula associated with this type of relationship that we have in this particular word problem. So varies jointly, we will be using joint variation, and by translating our variables to this type of formula, we'll have z is equal to kx square root of y, or simply z is equal to kx square root of y. So this is how we translated our verbal statement to its algebraic form by following our equation associated to this type of variation. And for our third example, we have z varies directly with x and inversely with y. So not only that we're using or working with two variables that will result to our output z, we're also working with two types of relationship, which is direct variation and inverse variation. So let's translate this into its algebraic form. So we are using z as our output, and it says here that we are working with z varies directly with x. So that means we have x, and we also have the constant k to build this type of relationship. And at the same time, it's inversely related with y. And inversely with y means 1 all over y, shows or represents inverse proportion or relationship with x and our constant k. And by simplifying this, we'll have x times k times 1 all over y. And if we want to simplify this, z is simply xk all over y, which is the simplest form of our relationship based on the verbal statement that we are seeing in our example. So using directly and inversely as our two relationship in this two variable relationship for z, will have combined variation that is translated into k x times 1 over y, or simply kx all over y is equal to z. So now that we're able to practice on how to translate our verbal statement into its algebraic form, we are now ready to work with word problems that will challenge us to find the value of the variable according to this relationship. So in this case, we have a quantity x varies directly with the square of y and inversely with the cube root of z. Now, if x is 6 and y is 2 and z is equal to 8, we need to find the value of x when y is 1 and z is 27. Now, it's a little bit too much to work on, but if we're going to organize our work, we simply need to produce 1, our equation, 2, finding the constant k, and then 3, answering the last part of this word problem, which is finding the value of x, given that y is 1 and z is equal to 27. So let's start with the first relationship that is shown in this particular problem. We have quantity x varies directly with the square of y, so square of y. So we know that if we're working with the first relationship, the constant k is always present, which is the unique number that is associated with the pattern in this particular relationship. There is another relationship in this word problem, which is inversely with the cube root of z, and we know that inverse means we're going to multiply this with 1 all over cube root of z, so cube root of z, and this is now how we're going to translate our verbal statement into its algebraic form. So we have x equal to y squared times k times 1 all over third root of z, and if you want to simplify the formula, it will be k y squared all over third root of z. And in this way, we'll be able to find the solution of our first part of the problem, which is finding the constant variation k, because we know that we're able to translate our combined variation from the given word problem having direct variation and inverse variation in one problem. We're able to translate this into x is equal to ky squared all over the cube root of z. And in this case, we know that x is equal to 6 from based on the given value of x in our problem. And then we also have y is equal to 2. And we also have z is equal to 8. So all we need to do now is to manipulate our fraction so that we can find the value of k. So how are we going to do that? So from this equation, according to our variable, our x is 6, and our y, let's change this into this color, 6, and then y is equal to 2, and z is equal to 8, and this is equal to 8. So by translating this, we'll have 6 equal to 4k all over the cube root of 8 is equal to 2 because 2 times 2 times 2 is equal to 8. So now we can simplify our equation by simplifying 4 and 2. So we'll have 6 is equal to 2k, and by dividing both sides by 2, we now have the constant variation k, which is equal to 3. And this is the value of k that we're going to be using so that we'll be able to answer the last part of our word problem. And the last part of our word problem is to find x when y is equal to 1 and z is equal to 27. So now our new equation or formula that we're going to be using to answer the last part of our word problem is using x is equal to ky squared all over cube root of z, but this time we are going to replace k, y, and z, which is given by y is 1, z is 27, and k, which we have found from our previous work with our formula, which is 3, and by doing our basic math skill, 3 times 1 is 3, cube root of 27 is 3, therefore x is equal to 1, and this is how we're able to answer this word problem involving joint variation. So your Numberbender challenge for today is for you to answer this problem right here. So if y varies directly with x and inversely with z, and y is 25 when x is equal to 10 and z is equal to 2, how are you going to find the variable y when x is 18 and z is equal to 9? So you have 3 steps to do this or to answer this correctly. 1, you need to produce your equation associated with the two relationships in this problem, and then 2, find the constant k, which is your constant of variation, so that 3, you'll be able to use your formula with your k value in this particular challenge. So for students who are working with relationship or numerical relationship, in these type of variation, we have direct variation, inverse variation, joint variation, and combined variation, and understanding that we are simply answering word problems by translating our verbal statement into algebraic form and then using our properties of equation to be able to solve for the variables that we are working for or we're trying to look for. We'll be able to solve problems like this really easily. This is Dr. E, and see you again next time.